All right, so number 6. So I'm going to start by drawing my picture. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, and then 5 pi. So 4 pi to 5 pi was one of these two quadrants. So far, so good? Okay. All silly turtles crawl. So looking at quadrants 1 and 2, tangent can be negative only in the second quadrant. So I'll draw my standard position angle here for theta. So far, so good? Okay. The alpha then is going to be this angle here, formed between the terminal side and the x-axis. Okay with that? And then I know that if we relate theta, alpha, and 5 pi, since the last axis that we crossed through was the vertical, I know that theta is going to equal 5 pi minus alpha. So far, so good? Okay. And alpha in this case is going to be tan inverse of the absolute value, negative 595. So we'll fire up our calculator. And do that, making sure our calculator's in radian mode. I know mine is. Notice that I did the absolute value there in my head by just dropping the negative sign, like I didn't bother to type into the calculator. So my answer should be 1430. I'll check that real quick. So I'm just going to take tangent of that answer to make sure I get negative 595, which I did. And then I want to check to make sure that 1430 is in between 4 pi and 5 pi. So 4 pi, it's bigger than 4 pi, that's good. And it's less than 5 pi, that's good. So I know that my answer is correct. Does that feel okay?
Yeah, that makes a lot of sense. It's not a key, I get like super precise.
Sure. Yeah, the way that I've shown you here in class, you can do it the exact same way for all of these, which is nice. Quotes. Ava.
Can you do number 11 on worksheet 1?
Sure. In case you might not have figured it out, I'm losing my voice here. I looked all over for it and I just couldn't find it. So I don't know what's going on. I'm sure it'll turn up when I stop looking, right? You said number 11?
Yes.
Okay. So let's start by kind of drawing our picture. 0, pi, 2 pi, 3 pi, and then 4 pi. I skipped drawing labeling the verticals. Is that okay?
Yeah, that's fine.
Okay. So we're looking at either quadrants 1 and 2, or I'm sorry, 3 and 4. If I do my all silly turtles crawl, I know that tangent is positive in quadrant 3 or quadrant 4. I know that's really quadrant 4. So if I draw my standard position angle, then that's my theta. So far, so good.
Yeah.
Now I'm going to look, or I'm going to go to the unit circle. I'm going to remember that tangent is y over x. But if I go look at the unit circle, there's no place where an x coordinate has a regular 3 in it. So what I'm going to do actually here is I'm going to reduce this fraction. So I know that 3 is the same thing as root 3 times root 3. So I'm going to rewrite this as 1 over root 3. So I'm going to look for a spot in quadrant 3 where the y coordinate has a 1 in it and the x coordinate has a root 3 in it. Now there's going to be some other stuff because I know that those aren't actually unit circle values there, but it's going to be good enough. So the y coordinate has a 1 in it and the x coordinate has a root 3 in it. That's what I said? Yeah. So I see there's my y coordinate with a 1. There's my, y coordinate with a 1, x coordinate with a root 3. So we're looking at the spot 7 pi over 6. Okay so far, Ava?
Yeah.
But that's not our answer because that doesn't lie between 3 pi and 4 pi. I noticed that when I look at my picture here that I drew, I went around one full time before I have to go my 7 pi. So I'm just going to add 2 pi to that. When I make my common denominator, that becomes 12 pi over 6. So when I add my fractions, I have 19 pi over 6. Is that cool?
Yeah. Thank you.
You're welcome. And again, the confusing part there was having to reduce the root 3 over 3.
Right. I couldn't figure out.
Yes.
Yeah.
Yeah. Again, not totally obvious without having like been shown that trick that like, aha, that's what I needed.
Mm-hmm.
So you may have to do a reducing or a rationalizing to peel out what exactly coordinate you're looking for on the unit circle.
Okay.
Great questions, guys. Hey, Ella. Sure. Let's see, worksheet 2. I thought I grabbed both pages. Apparently, I don't know. I felt better, so I'm going to blame it on just being a bit under the weather. So you're saying number 8. Great. And that's a good one to ask about because we have the negative coordinate there, right? Which makes life a little bit trickier. So we'll start by drawing our picture. So there's 0. That's negative pi over 2. That's negative pi. Remember, when we have negative angles, we're going clockwise rather than counterclockwise around. So we're talking about those 2 quadrants. So I do my all silly turtles crawl, and I can determine that cosine is negative in the 3rd quadrant. And again, since I know theta is a negative value, I'm drawing it the angle going clockwise rather than counterclockwise. So far, so good? Okay. So my alpha is this angle here. And if theta is positive, if the last axis I cross is the vertical, I should be subtracting alpha. But since theta is negative, it's all backwards. So I'm going to be adding alpha actually this time. So we'll say that theta is equal to negative pi plus alpha. Where alpha in this case is cosine inverse of the absolute value 0.62.
Wait, what are you doing?
Always. The alpha is always an absolute value. And the reason that is because the alpha is in a standard position angle. It's like, it is just an angle measure. So it's like you want your first coordinate value always for that. So that's why we always want it to be positive. If that makes any kind of sense. So that's negative 2.24. Just to double check that, make sure that it got it. That's definitely giving me cosine of negative 2.24 is giving me the right value. And definitely that's between negative 3.14 and 0. So I'm good. Does that feel okay, Ella? So the hardest piece there was the, because the things were negative, it makes the writing that little equation with the alpha and the theta in it a little bit more tricky or whatever. Just to summarize that, so if theta is positive, and the last axis passed is vertical, we would do subtracting alpha. And then if the last axis passed is horizontal, you'd be adding alpha. But if theta is negative, this is just reversed. So again, if you wanted to write that down or copy it down or whatever, that's, I think we said this aloud, but I probably didn't write it down in this fashion last time. So I just figured I'd write it down here for us. Again, if you prefer to just use that to write your theta alpha equation, or if you want to just write the equation from looking at the picture, either is okay. But Evan?
Can you do number 12 on the sheet?
Sure. All right. Okay. So first thing I'm going to do is rewrite this cosecant so that I can use sine, cosine, or tangent. I remember that cosecant is the reciprocal of sine. So I can replace cosecant with 1 over sine. And then if I do the reciprocal of both sides, because I got to get that sine theta out of the denominator, I have that. Good with that? And then I notice that this isn't a unit circle value for sine, but if I rationalize the denominator, I get a unit circle value. Okay. Then we'll draw our picture here. So 0, a half, 1, 1.5, because this is really 6.5 and 7.5. So I'm not going to write them all down because it's going to get really, there's going to be a lot of them. So I'm just going to kind of count and then just label the last time around if that's okay. All right. 0, a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. 7, and then 7.5. Okay. So we have these two quadrants. All silly turtles crawl. Sine is negative in the third quadrant, but not the second quadrant. So I'll draw this. So 2 pi, 4 pi, 6 pi, and then to my answer. Is that okay?
You know it's a negative because of like what it gives you at the start.
Right, because right down here I know sine theta is negative. Right, sine theta is negative root 2 over 2.
Yeah.
So I know sine has to be negative. That's why I'm going to pick the answer to be in the third quadrant, because in the second quadrant sine is positive. Cool? Okay. So here's my alpha. So in this problem I have theta is equal to 7 pi plus alpha.
I'm going to use y as a plus.
Okay. Oh, this is not a, sorry, we're on the wrong sheet. We don't even need to do that here. To answer your question, it's because the last axis we passed through was a horizontal, and we have a positive theta. That's how I know I'm going to be adding. We just wrote down that little criteria a second ago. That's how I knew that immediately. But this is not, I'm supposed to be using the unit circle to do this, so I shouldn't have even said that, but it's still relevant. You could still do it that way. So I go to the unit circle and I look in quadrant 3 for the place where the y coordinate is negative root 2 over 2. So that's the one I want. Cool with that? Okay. But that's obviously not my answer because that's not between 13 pi over 2 and 15 pi over 2. To get to that value, I went around 1, 2, 3 times before I got there. So I'm going to be adding 2 pi to this 3 times. So when I do that, that's going to be 8 over 4, 8 over 4, 8 over 4. So 29 pi over 4 is my answer. Is that okay? You don't seem convinced. Did I lose you on some of the arithmetic?
Oh. No, I think
Okay. Yeah, no problem. Anybody else before we move on to the next stuff? Okay, very good then. Doesn't mean we can't come back and still ask questions about this stuff later. It just means that we're probably done talking about that stuff for today. There was two more ideas from section 4.1 that I wanted to talk about real briefly before we move on to section 4.2. And they're just really two kinds of problems. Well, I should say that there's a notation thing I need to mention first. So we define this function like sine inverse, right? You guys remember doing that yesterday? Not yesterday, but last time. There's an other notation that we can use that means the same thing, that says arc sine. It's an older notation. It's less common nowadays, but it means basically the same thing. And then there's arc cosine, and there's arc tan. You can see that and just treat it as the same thing as an inverse. I didn't mention that last time. I slipped my mind.
So it's the same thing?
It means the same thing.
Okay.
Yeah, at least for us. We can treat it the same way. I think if you go back and you look at the exact definition, but functionally it's going to mean the exact same thing. I'd have to go back and look at the exact definition to tell you that they are indeed exactly the same thing, but for our purposes in this class, you can use them interchangeably. But I think that I'm almost certain they are exactly the same thing. It's just a notation. But I'd have to go back and really, it's been a while since I read that, what the definition of those are. Good enough? Okay. So let's ask a little bit of a thinker here. What's the answer to this? If I take the arctan of the tangent of 5 pi over 4. Who says it's just going to be 5 pi over 4? Since arctan and tangent are inverses, they should just cancel each other out, right? No, it's not that. It's not multiplication. That's a composition, right? Not multiplication. It's not that, though. Why isn't it not?
Oh, you're taking arctan the whole thing, right? No, you're not.
So remember, what is the range for tan inverse? It's negative pi over 2 to positive pi over 2. So tan inverse cannot output a value like 5 pi over 4 because that's outside of its range. Oh. So what should we do in this case? I mean, you could think about it that way. Like subtract 2 pi's until you get it down inside of that range. That may not always work with tangent because the period for tangent is pi and not 2 pi.
True.
So I don't think that'll always work. Rather, let's think about it this way. if I go to the unit circle and evaluate tangent of 5 pi over 4, I get 1. And then I go back to the unit circle because arctan is defined in this range. I'm just going to go and look in those quadrants for the place where tangent is 1, where y over x gives us 1. I know tangent is positive only in the first quadrant. And the place where 1 is, or tangent is 1, where y over x is 1, is the place where the x and y coordinates are both the same. That would be pi over 4. So as tempting as it is on a problem like that where we're evaluating to just cancel things out, can't do that. You have to really do it as 2 steps. You have to evaluate the inside and then evaluate the outside to make sure that you're actually getting a value that's possible to output. Is that okay?
That makes sense.
Okay. Again, not a big deal, but like that's something if somebody doesn't talk about it and show you, it's very likely you'd miss that concept, right?
You do one with arc sine or arc cosine.
Yeah, I mean, it doesn't, they're all kind of the same at that point. I'm going to do arc sine of let's do 3 pi over 4. So if you go to your unit circle and we look, what's the value of sine of 3 at 3 pi over 4? There you are. Root 2 over 2. Should probably just have copied that down here also. And then I know arc sine, the range for this is negative pi over 2 to positive pi over 2. Sine is positive in the first quadrant. So I'm looking for in the first quadrant where the y coordinate on the unit circle is positive root 2 over 2. That occurs at pi over 4. Evan, you feel good about doing that kind of thing? Yeah, it's, again, as long as you've been told, like, hey, make sure you don't just, like, cancel these things out and just go about your business, it's pretty straightforward, right? It's just avoiding that temptation, explaining why you can't really do that. Okay, one more example, and then we're going to move on and talk about some section 4 stuff. It's similar to what we just did. So here we're going to be looking for an algebraic expression for sine theta of arc cosine 2x. Okay. So on a problem like this, you want to start from the inside and work out. So if I take this piece, arc cosine returns us an angle measure, right? Is that okay? If I do cosine to both sides of that equation, That's equivalent to saying cosine theta is 2x. We okay with that?
So it's no longer inverse.
Well, right.
Why is the arc by the arc is only
So I did like cosine to both sides of the equation. And that part just cancels. Because 2x isn't really an angle measure that we can see, because it's a variable in it. I don't have to worry about what we had in the previous problem where like, oh no, this has to be like inside of this specific range. I don't have to worry about it because x is a variable, so it's fine. Is that okay?
Yeah.
Okay. So what I'm going to do now, cosine theta is equal to 2x, is I'm going to go back to my right triangle definition. So there's my right triangle with a theta drawn in it. I know that cosine is adjacent over hypotenuse. So this side should be the 2x, and that side should be the 1. Everybody's okay with that? So now what I have is really sine of theta, where theta is the angle in this triangle. Everybody's okay? So I use the inside part to build this right triangle. And now I can perform sine using that right triangle. So sine is opposite over hypotenuse. The hypotenuse we know is 1. How am I going to find that opposite side? Right now I don't have it. How can I find that? In a right triangle. Oh, nobody? In a right triangle?
Oh.
If you know two sides and you're looking for the third?
Add the two.
The Pythagorean Theorem. A squared plus b squared equals c squared. Right?
Right.
Yeah, you kind of. Other than like you just made something up and it resembled what the answer was. Everybody's good with that? Remember, the hypotenuse is always the c. So 2x squared is 2x times 2x, so 4x squared. And we subtract the 4x from both squared from both sides. And then when we square root both sides, I have that. Notice that I dropped the plus or minus and just made it positive. Why can I just make this positive and drop that plus or minus? How do I know that this is positive?
It's an angle.
Well, no. A is a side length.
Oh.
But it's a side length on a triangle. Can't be negative,
Yeah,
right?
That's what I was going at.
Yeah. Geometric reason. Everybody's okay still? Now, can I simplify this and just write this as 1 minus 2x? Square rooted 1, square rooted 4x squared. Is that cool?
Yeah.
No. You can't do that. You can't break a radical across an addition or subtraction symbol. You can do it at multiplication and division. You can break your radical, but you can't do it with addition and subtraction. So that's as good as you could really have done. So that's my opposite. So that over 1 is just that, and that's my answer. So again, the trick here is we're going to use the inside to build the right triangle, and then evaluate the outside with that right triangle that we just built.
Do we have a worksheet on this?
It's in the problem set. I know that. I have to go look at. I don't think there's another worksheet that involves doing this. Let's look real quick. No, 3 is word problems. Yeah, that's what we're doing next in 4.2. Okay. But I know in the problem set there's a couple for sure, and there's probably a couple in the review. Okay. That closes the door on chapter or section 4.1. Let's talk about 4.2. And this is a pretty short one. Let me just do this because I'm going to do it this way, I think. Okay, so we're going to define 2 terms to start. The first is called angle of elevation. And I'm not going to define this with words. I'm just going to kind of draw a picture to kind of talk about what it means. So let's say we have 2 people, one person standing on the ground and one person standing up on a cliff or something. So let's say the person on the ground, they have a line of sight that's like straightforward. Everybody's okay with that?
Yeah.
And then they look up to look at the person above them. This angle here is our angle of elevation. So that you can draw the correct picture in a story problem situation.
In case you're not running.
Yeah.
Very important.
So that's what we mean by angle of elevation. The other is, the opposite is the angle of depression. So imagine you're the person on the cliff. Your line of sight is straight forward. And if you tilt your head down to look at your friend, that's the angle of depression. And in this case, yes, those would be the same angles because they're alternate interior angles since your lines of sight are parallel. We okay with that vocab? Let's do a couple of examples now. So this says, Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? Okay. So I'm going to just draw this as if it was a triangle. So here's Christy, 200 feet. We're assuming that the Fisher Building is parallel or perpendicular to the ground, which I think is fair in all building constructions short of the, what building do we know is not built or perpendicular to the ground? The Leaning Tower of Pisa, those darn Italians. It's not their fault. Well, the ground was like sunk. It wasn't, they built it perpendicular, just the,
It's their fault for building it.
I mean, I guess, I don't know how you would have known. Yeah. So this right here is our angle of elevation, because we're looking up to the building, right? Everybody cool? And we're looking for how tall is the building. How would I solve for x here? No. You don't know two sides.
Oh, we know two angles. Oh, yeah, that's right.
Use SOHCAHTOA.
You find out the third angle.
Relative to this angle, this is opposite and this is adjacent. So tan 66 better equal opposite over adjacent. Multiply both sides by 200. That'll be it. Calculator time. Before I type this into my calculator, what do I need to make sure I do?
Make sure it's in the correct form.
You make sure it's in degree mode, right? I know that the last problems I was using, everything was in radian mode, so I definitely need to switch it. So 200 times tan 66, and about 449 feet. So far, so good. Let's do another. Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet up in the air. Oh dear. Says the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? So remember, the angle of depression is this one. That's why we needed to make sure that we defined angle of elevation, angle of depression to start, so we're making sure we're putting the angles in the right places when we draw our picture. Everybody's cool with that? So I'm just going to use the fact that we have alternate interior angles to say that that angle down there is also 49 degrees. Alternatively, you could have said that angle J, the other part of it, is 41. Like that would be okay to say also. But you need to get one of the two angles inside of one of the two acute angles inside of your triangle some way. Everybody's good? Then I'm just going to use tangent again. So tan 49 equals opposite over adjacent. I multiply both sides by x. And then divide both sides by tan 49. And then it's calculator time. So 14.78. So far, so good. Probably pretty easy so far, right? Let's do, I think, one more example, and we'll stop for today. This last example is the most challenging type. So Claude and Simone are riding bicycles in Paris. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5. How tall do they estimate the Eiffel Tower to be?
Still very humble.
Everybody cool with how I drew the picture? Okay. So, my plan here is I'm going to create a system of two equations, because right now, in order to solve this, I'm going to kind of need that section there. So the first thing I'm going to like to do is draw two separate triangles, just so I don't get confused. So what is this side length going to be at the bottom? It's got to be 100 plus y. Everybody's okay with that? So I'm going to write that tangent of 32 is equal to x over 100 plus y. And then when I draw the second triangle, I can say that tan 37.5 is equal to x over y. Feel okay there? I'm going to solve this system now using elimination. I'm going to get both of these equations equal to y and then set them equal to each other is going to be my plan. Everybody's cool with the plan?
Yeah.
Okay. The first equation, I'm going to multiply both sides by 100 plus y. And the second equation, I'm going to multiply both sides by y. And I guess really I could set these equal to each other right now and solve for y. That might probably be algebraically a little bit simpler. And then I can always plug back in and find that x later. Do you guys get what I mean? Y isn't really what I'm looking for, but look at it right now. Right, I can just set these two things equal to each other and then solve for y. And once I have y, I can plug it back into one of these and solve for x. That feels easier to me, so I'm going to do that, I think. Is that okay with you guys?
Yeah.
I mean, algebraically, you're kind of, it would make, we're really looking for x. We could find it directly, but the algebra is going to get a little messier doing that. So I'm just going to do it this way because it feels like it's going to long-term be a little bit neater. So I'm going to distribute that tan 32 through. And again, holler at me to stop if algebraically I lose you on anything that I'm doing. I got to get the y's both on the same side. So I'm going to subtract y times tan 32 to the right side. Now that both of them have all my y's are on one side, I'm going to factor a greatest common factor of y from the right-hand side. And divide both sides by tan 37.5 minus tan 32. Everybody good algebraically with what I've done to get to this step? Calculator time. So I'm going to use alpha y equals and select the numerator over denominator command because it'll make, this would get kind of hairy with the number of fractions in it. Or the number of parentheses in it, excuse me. But if I do it this way, it's, I can just type it in the same way it looks on my sheet of paper, which makes life a little bit easier. So y is 438.64. Did I say 38 or 68? 38. Okay. Everybody's okay there? And what I'm going to do then is I know that x is equal to y times tan 37.5.
Students who are traveling today with the Chinese classes for their field trip, could you please quietly wrap up your things and pack up your things and meet in the lobby? Thank you.
336.58. See you later. Have fun on your trip, Joe. You're welcome. And we're all done there. How's that sound to you guys? Okay. So the problem set for this weekend, I don't need you guys to do anything other than worksheets 1 and 2. I think that's plenty. For the next problem set, though, that's what, November 5th? 7th, I think, is Sunday. That's got to be right. I'd like you to do 1 through 18. That's 4.1 stuff. And then 19 to 23, those are 4.2 questions. And then worksheet 3 is a 4.2 thing. Right, okay. Worksheet 4 is... Oh, there's a worksheet with this that you asked about. Oh, we'll take a day and work on that next week or something. That'll be fine. And then I didn't... Worksheet 6, we're not doing that crap. Worksheet, okay.